let's do problem number 5. I'll read it. It says, a car is moving 30 meters per second and slows uniformly to 10 meters per second in 5 seconds. Determine the acceleration of the car, draw velocity versus time graph, and what was the car's displacement during the 3rd second. Okay, this is the part that students mess up a lot, so pay attention to this. So here's so let's see. Let's write out what's given. So we have a car. So here's our road. Here's our little car. It's a little Nissan Leaf, okay? So we're not hurting the environment. And the car is moving 30 meters per second, so V naught is equal to 30 meters per second. And it says that it slows uniformly to 10 meters per second in 5 seconds. So here's our car, changed shape for some reason. So its final velocity is 10 meters per second. And it took 5 seconds for this to happen. Now, as I was watching your solutions to the other problems, one thing I noticed is that except for the bear problem, you just did a great job with the bear, you guys aren't drawing pictures around what's given. Draw a picture of it if you can visualize the problem. Oh, you guys drew a picture too. I feel bad now. Yeah. But it's always good to draw what's given around a picture. And what are we trying to find? So it says, what was the acceleration? And then part B, we want velocity versus time. And then part C, let's see. Oh wait, I'm sorry. Draw. And then what was the car's displacement during the 3rd second? So delta x during the 3rd second. Now, when I use given, find, and solve, if I have something that's kind of weird, like this, I write it out in words. Sometimes it's very straightforward. The acceleration, velocity versus time graph. I guess I'll put graph here. Okay. This is for my dwell. Not here? Okay, not here. Yeah. Ooh, solve. So if I know the initial velocity, the time, the final velocity, I want acceleration, just use the first kinematic equation. And because notice in here, I'm not given delta x, and I'm not trying to find delta x, so I look at my little chart where delta x says no. That's the equation I use. And then, so then I can say, well, acceleration equals v minus v naught over t. You can also say this is delta v over delta t, because that's the definition of acceleration. You can use that as well. So this is 10 meters per second minus 30 meters per second divided by 5 seconds. 10 minus 30 is negative 20, divided by 5 is negative 4 meters per second every second. Whoa, what does the negative mean? Or our velocity is positive, but my acceleration is negative, which means that we are slowing down. We're slowing down. If the acceleration and the velocity are opposite in sign, then you're slowing down. You can have a situation where your velocity is negative, but your acceleration is positive. You're slowing down. Okay. And then for part B, well, let's see. What's the maximum velocity I'm going to get? Oh, I know my velocities are 30 and 10. So this is pretty easy. So 1, 2, 3, 4, 5. And then 5, 10, 15, 20, 25, 30. Stop it. So we're going to start here, and then at 5 seconds, we're going to end up at 10. And we're going to do that. Now for part C, this is the weird one. What is our displacement during the 3rd second? Well, what is the 1st second? From 0 to 1. What is the 2nd second? From 1 to 2. The 3rd second is from 2 to 3. So watch what I'm going to do here. I want to know what this displacement is. It's the area of that little trapezoid. Well, I'm going down by 4 meters per second. So 30 minus 4 is 26. 26 minus 4 is 22. So I know that this is 22 meters per second. And then this is going to be 4 less than that. That's 18 meters per second. And the width of this is 1 second. Now I can find the area of a trapezoid. I can break it up into triangles or rectangles, whatever you want to do. I'm going to do it 2 ways. I'm going to find delta x by using the second kinematic equation. And the second kinematic equation says the initial velocity plus the final velocity divided by 2 times the time. And so delta x will be equal to v naught is 22 meters per second for this time interval. It's like I'm starting the watch over again. And then plus v is 18 divided by 2. And then it's just 1 second of time that went by. So what is 22 plus 18? 40 divided by 2? 20. So delta x should be 20 meters. Now, I'm going to do it a different way just to check my work. Let's use the third kinematic equation. Delta x equals v naught t plus 1/2 a t squared. So delta x, well, what is v naught at the beginning of the second? It's 22 meters per second times 1 second minus 1/2 of a. What is a? A is negative, well, this should be plus, negative 4 meters per second squared times 1 second squared. So this is equal to, well, 22 meters per second times 1 second is 22 meters. And then half of 4 is 2. 2 times, well, 1 squared is 1. So we end up with negative 2, which is equal to 20 meters. It agrees. Now this, using this kinematic equation right here, is like finding the area of a trapezoid. Yes?
Yes.
And then using this equation here, it's like doing this. Finding the area of this rectangle right here, which gives me 22 meters, because 22 times 1 is 22. And then you have to subtract this little area. Well, it's a triangle, so the height is 4 times 1 divided by 2 is, but it's negative 2. We're subtracting it. We're getting rid of it. So that's another way of looking at it. So that is problem number 5, beaten to death. Yes?
Why do you want us to use the equations if we could just count it with the squares with the numbers on top?
Well, so the question is, why do we use the equations rather than just figuring out the area? Well, the thing that I wanted to see through this explanation is that they're one and the same thing. Like this was really calculating the area of the trapezoid, wasn't it? So you can do that. You can do the rectangle and the triangle. Oh, and this, though, is, well, it's not exactly, you're right, it's not exactly the same thing because we're end up finding the big rectangle and subtracting away that, where what would we do normally?
It's just adding up.
We would do this, right? So what is this? This is 18 plus this rectangle, or this triangle. This triangle has an area of 2 meters, and this has an area of 18 meters, and you add them together, you get 20 meters. So what I'm trying to show you is this: the kinematic equations are totally consistent with everything we've been doing before. All right. Any more questions? That is all.